The exponential function can be transformed according to all the same rules as other parent functions. There are a few basic questions to keep in mind when transforming exponential functions that'll make sketching easier. First, what happens to the asymptote? What happens to the point 0, 1? And what's the new y-intercept? So let's take a look at a few different examples to illustrate these points. So if we start from the parent function y is equal to 2 to the power of x, and we don't do any transformation, then the graph, as we've seen, is going to look something like this. And this is the point 0, 1. So that's what we're going to start from. Now, if we add 1 to the end of it, we know that that is going to be a vertical translation. I'm going to abbreviate that vertical translation, VT, up by 1 unit. So that means that our horizontal asymptote, which was y is equal to 0, is now going to be y is equal to 1. And because the whole curve moves up, the point 0, 1 is also going to move up to the point 0, 2. Now we could make more detailed sketches if we plotted more points, if we made a table of values, if we took more points through all the transformations, or if we used our graphing calculator. But for our purposes, for just illustrating what the transformations are doing, this is going to be enough for now. Now, what if we replace the x in the exponent with x plus 1? Well, we know that that is going to give us a horizontal translation to the left by 1. Now that's not going to change the asymptote. The asymptote is going to remain at y equals 0, but the point 0, 1 is going to move over and now become the point negative 1, 1. So it's no longer the y-intercept. Well, what is the y-intercept? Remember, the y-intercept happens when you set x equal to 0. So if we do that, we get y is equal to 2 to the power of 0 plus 1, or 2 to the power of 1, or 2. That means the y-intercept is the point 0, 2. If we use that information, we get a curve that looks like that. Not to scale with the other curves, but you get the idea. And that's going to approach the line y is equal to 0 as we move off to the left. Carrying on, if we multiply the whole function by a third, we know that's going to be a vertical stretch by a factor of 1/3. Now, that's not going to change the horizontal asymptote. It's going to stay at y is equal to 0, but it will make the y-intercept the point 0, 1/3 instead of 0, 1. And the whole graph is going to be vertically stretched by a factor of a third. Now, without the other graph here to compare it to, we can't see the effect, but y is equal to 2 to the power of x would be above this line here, because it would be, because y is equal to 1/3 times 2 to the power of x is stretched by a factor of a third, in other words, squished towards the horizontal axis. What if we multiply, or rather, what if we replace the x in the exponent with a third x? Well, we know that that's a horizontal stretch factor 3. Remember that when it's in the argument of the function, in with the x, it's counterintuitive. Now, if we start from the point 0, 1, stretching that horizontally by a factor of 3 is not going to move it because it's already on the reflection line, so that point stays the same. The graph is going to get stretched out, so I can try and sort of show that by making it broader like this, because all of the x values are moving 3 times out from the y-axis because it's being horizontally stretched by a factor of 3. If we multiply the whole thing by -1, we get a vertical reflection in the x-axis. That's going to turn the whole thing upside down. 0, 1 is going to become 0, -1, and the graph is now going to look like this. Note that that will change the range. And if we replace x with -x, we get a horizontal reflection in the y-axis. The y-intercept is going to stay at 0, 1, but the whole graph turns around like this. As we saw, this is the same as a half to the power of x. It gives us an exponential decay kind of pattern, going down, decreasing as you go to the right. So that's transformations of the parent function y is equal to 2 to the power of x.